So I'd like to recap about your assignment. Your assignment. Assignment 2, I already put on the e-learning. You can upload the tier. Basically, you can install Apache Hadoop or Apache Spark or Terraform. Okay. Only one. You can choose only one. Don't need to apply all. Only one. Okay. So for MapReduce, if you install Apache Hadoop or Apache Spark, try to do MapReduce for inverted indexing. Okay, inverted indexing. You can find some example on the internet and try to modify, try to install and make it successfully run in your environment. Okay, and the other one is Terraform. Okay, Terraform manage show how you can manage infrastructure as a code. Okay, so you can choose either one. Form 2 to 3%. Okay, as your team, and then you only need to submit one report, should not more than 10 pages, and then submit Monday, July next month. Okay, next month to e-learning. Okay, and do presentation during the class. Okay, like your first assignment. Okay, any question on the second assignment? Last week we have discussed this before last week. Okay. Understand? Give me one. Okay. Or you have any problem? No problem, Okay, thank you. You can ask if you have any problem with members and so on. Okay. So you should have I think last week I asked you to form a team already. So you should find your team member. Okay, either 2% or 3%, no problem. It's not individual work. It's not individual. Okay. So today we're going to talk about MapReduce. So if you choose the MapReduce, for example, either Apache Spark or Apache Hadoop, then this would be useful for your second assignment as well. Okay. So today our class we try to finish this, and then and cover this topic. Okay, so the main thing is the Hadoop architecture, and then also the HDFS. One of important thing of the Hadoop is the Hadoop distributed file system, and then the concept of MapReduce. This MapReduce not only in Hadoop but also you can find a library in Apache Spark as well. Okay, so Hadoop, introduction to Hadoop, understanding the HDFS and MapReduce architecture, and the a simple word count, simple word count. Okay, so word count example you can find plenty. Actually, inverted index you also can find. Okay, the inverted index. Okay, try to Google your own. Okay, for the example for the source code, and make sure that it can run in your own environment. So big data challenge, we need the new data parallel programming, okay, for the cluster or community of machine. So this concept of MapReduce is also actually is a data parallelization, data parallelization, okay, but the a bit different from ordinary. Actually, it moved the programming, it moved the function or the code towards the machine or working node that store your data. Okay, so that it will try to reduce the I/O time to you to transfer the big file, big data, big file from other places to the server. So it use the concept of cluster, okay, and then P2P, many cluster, many nodes, working nodes, and all the data are well distributed among the working nodes. Okay, so it create a cluster of systems, store the data in cluster system, and process the data sets independent of one another. Okay, so these are some challenging of the data landscape. Okay, so what is Hadoop? It's an open source data storage, okay, and processing API. So massively scalable and automatically parallelizable based on work from Google, Google file system and MapReduce and Bigtable. Okay, so current distribution based on open source and vendor work. So you have Apache Hadoop, which you can download from the official website. And then the other one, Cloudera. Okay, so Cloudera is carry the distribution with the company, try to provide the support for the open source, and they carry their own distribution. Hortonworks, Meta, Amazon Web Services, AWS, and also Windows Azure HD inside. Okay, so these are vendors. Some are without vendors. Some are, the rest are from Cloudera, Automate, and so on. They are vendors, and then they carry different distribution, okay, but based on the open source, okay, but since some they have extra library or extra functions. Okay, so Hadoop is a framework for running application on large cluster built of community hardware. In other words, a reliable shared storage and analysis system. Okay, you have Hadoop module, Hadoop common, Hadoop distributed file system, YAM, and MapReduce. So it's a ecosystem based on basic Hadoop. Okay, and on top you can, once you got the file system, you got the API, and then you can build other machine learning, other database system, or something like SQL. So you can build on top of this ecosystem. Okay, so the journey of Hadoop started Dove cutting my Caferella as a text search library, and then Google distributed system paper published. Then Yahoo hired Dove at 2006. 2008, Yahoo announced its search index was generated by 10,000 core Hadoop cluster. See, 10,000 core. Imagine how many working nodes. Let's say it's one working nodes have 4 core, or 4 core you divide by 4. Okay, you also have 2,500 working nodes. Okay, it's thousands of working nodes, thousands of computers with multi-core inside. Okay, so it add up to have 10,000 core cluster. Okay, at least you have 1,000 1,000 CPU with multi-core. You see, more than 1,000. Won the minute sort by sorting 500 gigabyte in 59 seconds. Within a minute, you can sort 500 gigabyte of data. No sorting. Popular sorting. What kind of popular sorting we have is bubble sort, right? Merge bubble sort and what binary sort and so on. So they are using this map reduce method, okay, using thousands of core, then they can able to sort, okay, in just 59 seconds. So actually map reduce can use for many things. It's not only for word count example. Actually you can one, you can discover more how to write map reduce function, map function and reduce function apply to other problem. But you have to change the mindset, okay, from ordinary programming, because it's use different kind of method called reducer and mapper. Okay, so you need to write mapper and reducer function, okay, and then from there you can do parallel processing. So more than half of the Fortune 500, Fortune 50, okay, use Hadoop, okay, or Fortune 500. Normally we call Fortune 500 of top company lah, okay, top company use a lot of them use Hadoop. So these are history. So company using Hadoop, this example. Why use Hadoop? Okay, this is example of instead of scale up, you buy a more expensive machine with a more core or with more memory with more gigahertz. So you have to scale out, meaning you have to use many similar processing power, but you do in parallel processing. So Hadoop is one example of you can do parallel processing in a cluster mode. Okay, and it use the concept of key and value. So you will distribute all these key value, the information by using the key and value pair, and then distribute them within the cluster. Okay, then it can do a very fast processing. Okay, so the Hadoop and relational database. Hadoop is analogy is like a train. It can do a massive load. Okay, and relational database more for the quick transaction. Okay, small transaction that you need a very fast transaction. Okay, and here Hadoop is you need a very how say very big volume processing. Okay, big volume processing. So affordable, when to use Hadoop, affordable storage for storage and compute. Okay, so you don't want to buy a very expensive uh, uh, storage system. Okay, they are purposely for storage. Is called storage area network, SAN. Okay, and for you to keep the thing and so on. So this use another approach. Okay, instead of use expensive SAN and so on. So your actually your computer, you can make use of the working node hard disk within the you can aggregate all the hard disks on the working nodes from your cluster. Okay, you can group them all together, combine them. So you don't need to buy very high-end storage server. Okay, you don't need to buy a very high-end storage server. and yet you can achieve very fast processing. Okay, structured or not, okay, and resilient auto scalability. Okay, but for relational database, more for interactive reporting, multi-step transaction, and interoperability. Okay, so they are different. Don't think that Hadoop is a better technology, more recent, so it can replace a relational database. No, each of them have their uh, own advantages, have their own benefits. So it's not replacing one technology with another. It's just that you can use the new technology in different scenario, in different condition, to make things run faster and better if you use if you use old technology. But some like technology like relational database, they also improving. You also have a parallel DBMS. You also have they can make use of database on the cluster as well. Okay, that can guarantee the consistency level, like what I say, like acid, atomicity, consistency, isolation, and durability. So they can support this as well for relational database, which the consistency in, for example, ACID consistency level for them is very important. Then for relational database, this is the key features, key important things that you require. Let's say, for example, your company require very high consistency ACID, then you still can you still need to choose, for example, something like relational database technology. Okay, comparing RDBMS versus Hadoop. So data size, gigabyte or terabyte. The other one petabyte to hexabyte. Okay, so uh, mean the Hadoop map reduce, you can make use of more data because you glue all hard disks from different server. You can make use of all the server hard disks. So in theory, mean your storage is unlimited, because the more server that you add into the cluster, then your storage will grow. Okay, it will grow. Okay, access, interactive, or batch. The other one, Hadoop, more for batch processing, not interactive. Okay, updates, read or write many times. Then for Hadoop is write once, read many times. Okay, so a bit different. For structured static schema, okay, for Hadoop, dynamic schema, okay, and the integrity very high. The other one is low. What I mean, acid lah, just now I mentioned. Scaling non-linear. Here linear mean the more you add, the more throughput it can give, or the more storage it will have. Linear. Okay, so it will have when you add more server, your performance become better. Okay, linear. The other non-linear mean the more server you add, but they have a certain kind of bottleneck. So the moment you hit the bottleneck, you hit you reach the maximum performance. There's no point you add more server because it cannot contribute further. Okay, because the scalability have limited. Okay, it's not necessarily the more you add machine, then it will perform faster. Okay, query response time can be immediate. The other has latency. Okay, Hadoop and its characteristic. Okay, Apache Hadoop is a framework that allow the distributed processing of large data set across cluster of community computer using a simple programming model. Okay, it is open source data management technology with scale out storage and distributed processing. Okay, again, here scale out means the more hard disk you add from other computer, then it keep on increasing. Okay, you don't need to replace your hard disk. Let's say not enough 500 gig, then you buy 1 tera. Now not enough 1 tera, you upgrade to 2 tera. No, you don't need to do that. You just add, buy a new hard disk, add to the new server, and then the old server, whatever hard disk is just, it still remain there, it still use it. The moment you just add, then it will increase. Okay, you don't need to uh, reformat your hard disk or whatever, then migrate. Okay, so these are the some characteristic. Okay, Hadoop distributed file system distribute and store data across a cluster. Okay, Hadoop map reduce. It provide a pair programming model and move computation to where the data is, and handle scheduling automatically. Okay, and for tolerance and status reporting and monitoring. So there are two important components here for Hadoop. One is the file system, another one is the programming API, okay, or programming model, okay, that make use of. One is called mapper, another one called reducer. Okay, and then the program will schedule itself, mean how it move the computation to where the data is actually transparent from the programmer. Programmer don't need to worry about, oh, I have to move this function to execute in computer A. This one have to execute in computer B. You don't need to worry about all this. So they will know how to do data parallelization behind the scenario. So when you write your program, sometimes you don't need you don't understand the logic behind, because it already do something for you. It's not a simple statement and for loop, if then else. Everything you need to do your own. Sometimes everything you do your own, you can have a better understanding how the program work. But when you use a higher library, sometimes you don't know how it works, because certain library are hidden from you. It's do behind as a services, as a middleware. Okay, middleware. So actually Hadoop is become a middleware. Okay, because behind it do something using, for example, scheduling, how to move the data, how to store the data in which cluster, and how to move the computation. It's hidden from you. Okay, so Hadoop. Now we talk about file system. For example, you have a block size 64 megabyte. Okay, uh, block size, and replication factor is 3. Okay, so what does it mean, block size and replication factor? Anyone? You want to try? What mean replication factor? Ibrahim, you want to try? What is replication factor? Ibrahim, Abba? I say replication factor is 3. What does it mean? You can open your mind. Only one want to help. Okay, Zhao Jing say 3 copy. When replication factors, if you keep a file, you will keep in 3 places. Okay, you have 3 copies. Correct. Thank you, Zhao Jing. Okay. Okay, and what is block size? Iban Pillai, what is block size? Do you understand block size? Want to try? Ayub says size of data. No. Like a packet, something like that, but not very clear. Piban, Pilai, are you there?
Yes.
Yes. What is block size?
Sorry, actually no idea.
Oh, okay. So you say don't know lah. When
Yep.
you reply to me lah, so that I know you are listening to my class.
Okay,
Okay.
sounds good.
Okay. Thank you. So block size, when you see the storage. For example, when you see the storage, right? I say see a storage. See a file system lah. Okay. Let's say documents. Okay. So you see here size, right? How many kilobyte? Okay. Kilobyte. So these are the file size, but these are not block size, file size. Okay, so here if you see the hard disk, can I see the hard disk? Can I see a hard disk? Okay, so here, let's say I see the hard disk. Okay, type 3, 200, 200. This one, because I'm using a window file system window, so you can't see the block, right? When you use the Unix file system, you can display also how many block. Okay, normally your hard disk, you have a raw data, raw storage. Let's say when you are not format, you have a raw storage. After you format, then it will divided. It will format according to certain block. You have many blocks. So your hard disk consists of many blocks. Okay, so each block depend on how you want. You can your block you can put either 64 or 128. Okay, of bytes. Okay, so for example, if you have uh 100 gigabyte, then your block is 128. Then you just divide lor. You have you will how many block that your hard disk got. Okay, so it's a logical. It's like a logical storage of your hard disk. Okay, logical storage of your hard disk. So your hard disk divide into how many block. Okay, so each block consists of 64 meg. Okay, so it will become how many byte? Let's say you divide into as a 64 megabyte one block. So your, let's say you have 1024 or around 1024 lah, 1000 block, okay, of the hard disk. So you 64 meg you multiply by 1000 lah. Okay, so megabyte, it will become 64. How many? 64 giga, right? You will have a 64 gigabyte of storage. Okay, so you 64 gigabyte of size of storage, gigabyte, and then you have actually 1024 block. Okay, consists of, each of them is 64 megabyte. One block 64 megabyte. So and then your file size, let's say file size sometimes is you can more than 64 meg, right? Your file, just now I show a very small file. right? Here just now show in document. Document is a very small file, right? So my document is only a few 2000. Okay, 2000 is 2 meg. Okay, these are 20 meg. Okay, okay, some are 20 meg. Oh, these are very small file. Okay, so biggest one is 20 megs. 20 meg. Okay, so if I put in one block 64 megabyte block I say just now I have IPS guidebook IPS guidebook just now 20 meg. How many block do I need? How many block do I need? Zhang Tao, are you there? Zhang Tao? Let's say I got one file which is 20 meg, 20 megabyte. How many block do I need to allocate to store a file? Just now one person, Dayuk say one. How about others? Okay, Zhang Tao say one. Okay, okay, okay. The answer is one because 64 meg is more than more than your file size, right? So you don't need many block. One block enough for you. You have actually more than enough because your file is only 20 meg. For example, now you are doing big data processing. Okay, so big data processing, your files is you gather a lot of file that you put in a batch file, and then each batch file is actually you using a crawler to crawl information from whole world internet URL, whatever information they add, then you newly added. So you crawl this information and then you dump append into one big batch file, and then later you do a batch processing. So in terms of that batch file, let's say now you have 500 meg, okay, 500 megabyte, okay, 500 megabyte. So now what is your uh, what is your block that you require? Okay, 500 divided by 64. Okay, correct. So it's 500 divided by 64, but you should use a higher number. Let's say it's 8 point something, you have to use 9. Okay, so the moment point something, you have to delete the point and plus 1. Okay, you round up. Okay, 8.2 or 8.1, for example. What is 500 divided by 64? Calculator. 500. 500 divide 64. 500 divide 64. 7.8. So round up is 8 lah. Okay, so round up is 8. Okay, so how about if I'm using a 128 block size is 128 megabyte, and then my file size is 2 gigabyte. 2 gigabyte. Okay, so what is the answer? Anyone? My file size is 2 GB. My block size is 128 megabyte. How many blocks do I need? 16. Oh, how you get 16? Give me the calculation. So, okay, 2000. Correct. So 2000, 1024 times 2 divided by 128. Okay, so these are the way of getting how many blocks for one file. Okay, so now you all understand the meaning of block size. Understand, give me 1. Don't understand, give me 0. Now, do you understand what is block? Okay, good. Okay, so now, for example, I have a file. Okay, and then here this file is require 5 block. Okay, so 5 block. What is the file size that you can have? What is the file size? Okay, now let's say a file now consists of 5 block. What is the file size? Anyone? What is the file size? Let's say now I have a file called ABC. This file called ABC, I require 5 block. What is the file size that I can have? Class? Ibrahim, are you there? Oh, somebody give answer already. 5 times 64. Is it correct? Who give the answer? Zhao Jing. Are you all agree 5 times 64, the file size? Or can be other answer? Iban? Are you agree with the Zhao Jing answer? The file size is 5 times 64. Are you okay? Agree or you not agree? Tayyub agree. How about Tiban? So agree. Okay. So I say I'm not agree. I'm not agree with Zhao Jing. Can be other answer. Okay. The correct answer is the file size will be more than 4 times 64, and it will be less or equal to 5 times 64. So it's a range. It's not necessarily 5 times 64. Where can 5 times 64? If my answer can be 4 times 64 plus 32, can or not? 4 times 64. Okay, let's say 2, 5, 4, 4, 16. 16, 64, 2, 5, 6. 2, 5, 6 plus 32. 2, 5, 6 plus 32. 288. If my file size is 288 megabyte, 288 megabyte, I require 5 block as well, right? So not necessarily times 5. Mean is within that range. More than 4 less than 5. More than times 4, less or equal to times 5. Okay, these are correct answer. So for example, let's say block 1, this server are down, where you put block 134 there. Okay, so you still can recover 134 because you can get all the answer back from different server. Okay, so let's say initially 1, 2, 3, 4 you get from however this server down, but you still can get back the 4 from other machine because each block you make 3 copies. Okay, so no problem if one of the machine down. So this one mean it will become high availability, HA, high availability. Okay, so if your machine down, your file is not still can recover. Okay, because other block keep in different machine. Okay, so Hadoop file system consists of name node and data node. Okay, name node is a storage size master of the system. It maintain and manage administrative data block present on the data nodes. So name node is like a catalog. Okay, catalog that know where the data keep and so on. Data node is the slave machine which provide actual and redundant storage endpoint for client read and write operation. Okay, so in order for you to have high availability, so because name node is use centralized approach, so if your name node down, so you cannot get access to your data node because the system didn't know where it keep. So in order to have a better high availability, then you can use a secondary name node. Mean if the master name node down, another name node you still can access to it. So you make a copy, then it will increase the availability. Okay. So Hadoop high level architecture. Okay. So sometimes you not necessarily you use bigger block size better. Depend on average your file size. Let's say your file size is very small. Most of them are smaller, very small. So if you use 128, maybe your block is unoptimized lah, because you are one big chunk and then you will not well distribute. Okay, so if you are using smaller block size, your data will be distribute more evenly in different computers. Okay, but the thing is if you're too small, then you remember what we discussed in earlier one is called the grain size problem. The ratio between computation and the I/O should not be too fine, too close. Is if possible, your computation need to be big enough compared to your I/O. Okay, ratio of I/O. So if the I/O time is too big, then you will incur a latency. Okay, so the block size also cannot be too small. Okay, so it's either 64 and 128, and then when you choose either 64 or 128, depend on your hard disk and your file size average. Okay, if your hard disk is very big and your file size normally is very big, then you can choose 128, else you choose 64. Hadoop high level architecture. Okay, you have a Hadoop client, name node, and then you have a job tracker. So the job tracker is what the use of job tracker and so on, because here it work hand in hand. Mean the Hadoop framework is actually consists of storage and computation. So storage part handled by the HDFS, Hadoop file system, which you keep in name node and data node. All right, you keep your data in the name node, and then sorry, you keep your data in the data node, and then the name node is just register where the location and so on, the catalog of this information where you distribute your data. So and then use the concept of block, multiple block, and distribute accordingly to the machine. And then you still use the concept of, because your block and so on, usually your block have the content. The content, it keep the information in the block. The content you use the value of your content can be one of the key, can use as a key. Okay, maybe the first element of the block, okay, will be used as a key, or you can name the whole block. The whole block can be used, the name of the block, okay, can be used as a key. So the block ID, where is the physical block of the hard disk? Is not the user choose it. The user cannot choose, I want to store in machine 1 or machine 2 with block ID 3412. Let's say you have thousands of block. Each block got block ID followed in certain order. You cannot choose, user cannot choose which order you want or with what ID. No, these are automatically chosen by Hadoop file system based on the content. They're using a concept of called hash key. Okay, using a hash value, hash function, distributed hash function from your files and so on. So it will automatically put in whatever block in which machine by the system itself and register this information in the name node. And then when you want to access to this information of the data within the node, for example, the data within the node, the block, okay, so you want to access that information, then you use the concept of map reduce. So when your you map you use a key and value, mean the value is keep inside the block lah, inside the block of the content, whatever block. And then the job tracker will execute the command, the function, the mapper that have the value inside that block in that computer. For example, it will execute the function. Okay, in the other computer which have other value in other block, so they will also execute the mapper on that other machine. Okay, so the function of the mapper depend on the working node, whatever information reside there. Then that mapper, according to the value of the block, will be executed. So you don't need to move your data to the server. Instead, the function will execute accordingly to whatever you keep the data there. So these are hand in hand. So it will map reduce, the job tracker are doing that part. I'm not sure you follow or not. Do you understand? If understand, give me 1. Don't understand, give me 0. Or 50% understand, 50% not understand, give me 2. Nobody nobody reply. 1 don't understand, Dayup don't understand. The rest all understand lah. 2% don't understand. 3% don't understand. What? All don't understand. 0 mean don't understand. All don't understand. So how to explain? What you don't understand? What don't understand? Never mind, we go further, because we go further and then you think back on what I'm saying here. You relook back on my video, what I explained here. Because now I'm go directly to the technical detail on how the scheduling work behind, which is not teach by, usually not highlighted by the programming part, because programming didn't show that. The programming is you just write a mapper and reducer. Okay, it didn't show that. So I'm talk the technology behind how the library, how the middleware work. So it's a bit how say, deeper, rather than you do a map reduce programming, map reduce function, because that is uh, on the program side. It didn't tell you how the execution work. Okay, so when we see the program, how the program, you write the program, and then later on, then you think along what I'm saying, then you try to you try to understand what I'm saying. Okay, because it's hard for me to highlight further, because I don't understand what you don't understand. Okay, tell me the block of location of the results. Okay, so for example, it say each a client asks, okay, I want to access something, and then you say, oh, block A here, block B here, block C here. Then the client will go accordingly to what block to get the data back. Okay, so for example, result A, result tag consists of 3 blocks, which can get from certain data node. So this information are captured in the name node, and then client will accordingly to fetch the data node accordingly. Okay, they have certain choices lah, more option lah. Okay, because it keep 3 copies. Okay, it keep 3 copies, so it have more choices. Then he said, I want to write a block ABC of file.text. Okay, so okay, write to the data node 1, 2, 8. So it can write there, and then after that, then it will do a replication later lah. You write first to the block, and then because you have replication 3 copy, then after you write, then it will replicate. So the consistency is not immediate. So they have some thing after you write. Okay, the A, B, C, and then let's say the system down and so on. Then when you go, actually your data not yet replicate, right? Not yet replicate, because you only write to A, B, C only. So it's not when you write, you must replicate immediately. No, you write directly to data node and then replicate it later. Okay, a Hadoop distributor file system that manage the storage across a network of machines built around to handle very large files, terabytes, petabyte, okay, and so on and so forth. Okay, so these are the ecosystem of the Hadoop. Okay, for example, you have HDFS, you have HBase, you have Hive, do a business intelligence, you have big ETL, okay, transform and loading. I forgot stand for what. Extract, transform, and loading, I think. and scoop for RDBMS. Okay. So these are example of file system, Hadoop file system. You can make directory, you can LS, you can copy. It's um it's like how say, it's like a cloud file system or distributed file system. Mean when you, for example, let's say when I access to here, for example, this one, I open a document or file explorer. Here I'm using a local file system. Mean whatever file keep here is within my computer only. Okay, within my computer, these are the file, okay, folder and so on. But for example, if I'm using a distributed file system, then your file are stored not only one computer, is actually inside a cluster, and then the block are distribute around in, some I keep in your computer, some I keep in other computers. For example, your computer is one of the cluster, one of the data node. Okay, one of the data node, for example, one of the uh, working node lah in the Hadoop cluster. Then you have two file system. One is your let's say you are installed in Ubuntu, for example, you are using Ubuntu. Then your local file system Ubuntu, you have one copy. Okay, and this server also uh, uh, part of the cluster. Okay, it's also part of cluster because you install something there, something Hadoop on this Ubuntu machine. Okay, so and then your Hadoop, let's say, consists of five machine. So you have two file system already. One is a local, your Ubuntu local file system, or Windows just now, like Windows file system, your own. Another one is Hadoop, which is, I call it a cluster of global file system. You have local file system and global file system. So you can move upload or download to global file system. So it's something like, once you have this one, is something like you have Dropbox. Dropbox, for example, is a cloud file system, cloud storage, right? Dropbox. So you can drag your thing into a Dropbox. Okay, put on the cloud. So same, when you have Hadoop file system, you can upload into Hadoop file system. So the moment you close your machine, you go to another machine, let's say you find machine there. So you switch off your machine. Remember, because you make 3 copies. So you go to other machine, you still can access whatever file you have upload. Okay, and then your machine can be down also, because if you have you are using a replication copy 3, for example, or more than 2, then you can take back your whatever, even your server down, your machine down, you still can have back your file. So this is a mean for you. You can upload or download. Okay, you can copy, you make directory, you copy, you put, and so on. So here it use a Unix command, because Unix command normally these are same. For example, cat mean you want to see the content. Mkdir mean you make directory, you make create a new directory. Okay, a copy from local. Okay, you upload it to the Hadoop file system, and then you put, okay, or you put local file to the Hadoop file. Okay, same, you can copy from local, or you can put, okay, or you can use a get, okay, get HDFS, get user Hadoop file to local. So you can upload or download. Okay, up to you. Okay, these are using some Fazilla. Okay, the other things. So I don't have hands-on here lah. Okay, for you, you can do the, how I say, Hadoop you can install in your own cluster for your second assignment, and then you can demonstrate lah. For example, once you have done this, you can demonstrate if you are using Apache Hadoop. Okay, you can demonstrate in your second assignment. Okay, so just now is I highlight the storage part. Okay, and another one is the computation part. And later on, you will understand what I'm saying. It work both hand. Computation and storage are work hand in hand. One is like left hand side and now right hand side. Then you will do scheduling it on. Okay, so the MapReduce is a programming model for processing large data set with parallel distributed algorithm on cluster. Published 2004 by Google engineer Jeffrey Dean and Sanjay. Okay, and later on, see some of them engineer are quit from Google and join Yahoo, right? So then they will they come out sort and so on. So these are MapReduce. Let us consider this one. These are simple of doing parallelization. You when you parallelize the problem, then you will doing faster. Okay, so if one computer do 100 hours, okay, you are using 10 computers, then you send the job workload there to complete, then you can complete faster in 10 hours. These are theoretically lah. Okay. So the problem of MapReduce is like maximum stop level, span of 5 years, the identify personal identity information. These are example. There are much more example lah. That you can do sorting. Just now, like you can do sorting, you can do inverted index and so on. So, and example of traditional solution is you have a very large file, big data, and then what you do is you split the data, and then you find the grab mean, you find the pattern that you're looking for, and then you concatenate. These are example of traditional one. Then using a MapReduce one, what you do is the big data you split into split data lah. When you split the data, it will split according to this one. When you go further, it's actually into many data block. Okay, into many data block. But if you use an example very small, then you only make use of one big block. Let's say your block, your data is only few K, and then your one block is 64 meg. Then in that thing is still within a computer lah, within one block. So actually, when we do a word count example, sometimes you didn't get a very impressive, very good result because of your data size. Data file is small and the block is too big, and then it didn't execute in different computer, everything actually within the same computer. That's why that week last time I forgot the student name, one of the classmate here doing presentation. Apache Spark is much faster because everything still within the same computer. You might as well everything you load into memory, and then you work faster, right? Because it didn't, the data size, it didn't add beyond one block, beyond many blocks, and all these blocks are on different computer, then they can execute in parallel. Okay, so when you demonstrate actually your data, you need to do tuning also. Okay, sometimes you need to do certain tuning. Okay, so some people they are tuning the map reduce framework into faster, but these are really expert lah. When you do tuning, normally it's hidden from programmer. Programmer cannot see all how to do the tuning because optimization is done behind. Okay, optimization is done behind. You have no control. You just put the data and then it will do themselves. It will do automatically where to execute in what machine, what server. You have no control. This is what I mean it just now. Okay. So map reduce features, large scale distributed data processing, pair programming, and so on, load balancing, handling machine failure. Okay, so the thing is it try to make it easy. The programmer just thinking of mapper and reducer because the load balancing and handling machine failure are done by framework itself. Programmer no need to worry about this. Okay, how to scale large data processing application, divide the data and process on many nodes. Each such application has to handle communication between nodes, division and scheduling of work, fault tolerance and monitoring and reporting. So map reduce, handle and hide all these issues, provide a clean abstraction for programmer. Okay, so programmer don't need to worry about division, fault tolerance and monitoring and communication between nodes. And locality job tracker divide tasks based on location of the data. It try to schedule map tasks on same machine that has the physical data. This is what I mean just now. Okay, when your mapper function run, so the job tracker, a scheduler, it will execute the map task on the same machine that has a physical data. They have the physical data. They don't go to different machine that don't have that physical data because remember the when we have HDFS, your data consists of many blocks, right? Your text file, result file or text file, let's say a very big text file. Your physical data is a huge, let's say is a 100 meg or 100 gigabyte, let's say 100 gigabyte. So 100 gigabyte, you require many blocks, right? Many blocks. So all these blocks are on different machine, can be on different machine. So when your one of the block within your local machine, so the mapper function execute only on that machine that have that same physical data, have that physical data. Okay, it won't run this mapper function on the other machine because the data is not there. Okay, so these are the thing called locality. Parallelism, map tasks run in parallel working different different input data split. Okay, and reduce tasks run in parallel working on different intermediate key. Okay, and reduce tasks, wait until all map tasks are finished. So fault tolerance, job tracker maintain a heartbeat with task tracker failure are handled by re-execution. If a task tracker fail, then all tasks scheduled on it are re-execute on another node. I think you're all tired. You want to have a break or continue? Anyone? Continue or finish it? Then no break? Or you want to break 5 minutes or what? Okay. So since actually in here today is a public holiday, but I cannot finish it, so that's why we still have class here. So, but however, I want to finish the slide earlier. So we have a short break only, and then later on we try to finish not 9 o'clock, maybe 8 o'clock or 8 something we finish it. So we finish earlier, and then we have short break. Okay, give you a short break, 10 to 15 minutes. Okay, so see you at now is 7:28 my time. So 7:45 lah. Okay, 7:45 we continue. Okay. Yeah. Okay. We finish earlier. 8:30 should finish already. Okay, Dayup. Okay, no problem, no issue. Okay, 7:45, around 7:45. See you again. Oh, sorry. Luckily you highlight. Oh, my face disappear. Okay. So the here, for example, mapper input key offset value or line of a document. Okay. And output. Okay. For each word in input file, output key and W value, key with W, word key is the word and value is 1. Okay, so input 2133 is a key, the quick browse fox jump over. This one key is the offset. Okay, value is line of document. Offset mean for example, you have a file. Okay, file start with location 0. Okay, next line, maybe offset is location is 101. And next line, next input is 500. Next one is 1200. And next one is 2133. Offset from the or the beginning of the file. Okay, these are example only, like example only, input 2133. Okay, reducer keyword input key word value list integer. Okay, sum all value from sum all values from input for the given key input list of value. Okay, and output key word value count. For example, input the 11111 and then fox 111, output will be the 5 and so on. So the input will be word list of integer, output will be sum all value from the input for the given key input list of value. Okay, so these are easier to understand. So understanding the map reduce, for example, K1 V1, okay, and then output K2 V2. Okay, K1 V1 info input split and list of K2 V2, and then after that we will suffer and sort one about list key value out intermediate, one list per local node. Okay, and can implement local reducer. Okay, map. Okay, after the list and suffer, then you will get a reducer K2 list V2 and then list K3 V3. Okay, so these are the sequence, the process lah. So K1 will give you the input file with the value content of the file, and then your output for example, each sentence inside the file, you take out one word, okay, the, or brown, or fox, or elephant, all the word, okay, and then list of v2. Here v2 very simple in word count is everything will be output as 1, okay, because it will keep, it will generate as an occurrence. Only it will v2 have a constant value as 1. Okay, and your list of v2 after that, you have a series, a sequential, a list of 1, a list of 1, value of 1. So if happen 5 times in your document, so you will have an array of 1, 1, 1, 1, 1, 5 times. Okay, if appear 2 times, then you will array 1, 1, 2 times. Okay, so these are reduced. And then finally, you will a list of words with a number of occurrence. Okay, so method to write. You can see there are many examples in the internet. You can get the basic one is actually from Java code, word count Java code, and you also can get the from Python also. Okay, example Chao Ting also have done this one. Okay, so you can actually execute in. There are many MapReduce also exist in quite a number of languages. Okay, once you install the Apache Hadoop, then you can use a different client library, write in your own preferred programming. I have tested 2 before, one in Java, one in Python. All have no problem. Okay, no problem of executing. Okay, so there, for example, you have input, you give one big file, for example, and then you will do a splitting, deer, bear, river, and so on. Then after that, map process. Okay, let's say you have one big file, then you give in this one as a key. The key is the location. Let's say your key can be, I make it simple, block 1. Okay, block 1 you have deer, bear, river. Block 2 you have car, river. Block 3 you have deer, car, bear. Okay, deer, bear, river is the content, is a value. Block 1 is a key. Block 2 is a key, the value is a car, river, okay, and so on. After that, the mapper function will generate from here, it will take out each word. So it will generate intermediate key called key2, list of key2 value, okay, key2 v2. The v2 here is always 1. Okay, v2 always have the value of 1. So v2 become constant. Okay, always 1, 1, 1, 1. But the key2, K2 will become the word that exists in your block. Okay, the word that exists in the block. So the first word will be deer, the second word will be bear, third word will be river. These are your K2, key2, key2, key2. So each function, let's say these are in computer 1. Computer 1, block 1 will generate this one. Computer 2, block 2 will generate this one. Computer 3, block 3 will generate. I use example. In real one, all can happen in one computer. Okay, all this can happen in one local computer. Let's say you just install single node. You are not using a cluster multi-node. So you are single node only. All these are within one computer, done, finished. Okay, but imagine that these are very big block, data block, 64 meg. So you have plenty of information there, 64 meg. This is another 64 meg. So it will, and then you have 3 machines, for example. It can be here in machine 1, machine 2, machine 3. Okay, after it do the suffering, okay, then you have bear, car, deer, river. Okay, so depend on the key that inside here. So the number of key 2 will equal to number of reducer that you have. Okay, so because you have four number of key 2 is 4, so you have 4 reducer. Okay, so 4 reducer here, you will have the same key 2 input go inside key 2, same value 1 will go into same reducer, same partition, so it will total up. Here 1 1 will become 2 k, 1 1 1 will become 3, and so on. It will total up. Okay, so here at the end you will have what kind of bear got 2 occurrence, car will got 3, here will got 2, river got 2. Just now in the beginning I say that you might confuse, you don't understand, mean the mapper here, the function of mapper here will run on this block, this data block. For example, the mapper function of this data is, let's say, reside in block 1 in computer 1. So the mapper of Deer Bear River are executing on the machine 1, on block 1, because the content is called Deer Bear River. So the machine 1, the mapper, it won't go and execute called Car River. If a Car River exists in another block in computer 2, but you are running the mapper function, which is Deer Bear River, then it doesn't make sense. Why? Because it need to go into the other machine. The data is not there. So the data and the mapper function are left hand and right hand. They always use the data within the same physical machine, local machine. The block is Deer Bear River. The mapper function, the key that generated is Deer Bear River. The key that have the key 2 value that it generate out is based on the content of the the block 1. And also when you split this Deer Bear River block 1, the mapper function run, it must coincide with this block 1. It cannot go to block 2 on the other computer and execute the content there. Okay, must jive. So the mapper always run on whatever data available there. Okay, the function there. This is what I mean just now, the concept of this. And then for example, when you do a suffer to reducer, also the same thing. Okay, and suffering when for example a lot of after that you generate this information, and this information will be, for example, in machine 1, there are many words on bear. Machine 1, many words on bear. So the suffering, you look at that, oh, you have many key generated key 2 are bear. So I group them together from bear, from machine 1, and other machine that maybe a small part will transfer to here. Okay, for example, machine 2 got a lot of information for car, so they have 2 car there. So other car from machine 3 will pull the data there. Okay, will send the data there. So this suffering and sorting or whatever also done by the system that you cannot see. You cannot see it. Okay, the programmer do need to write that. Okay, so the hands-on, you can see from the source code example from the internet. Okay, and from there you can understand better. So I think that's all. I actually got hands-on. I can maybe later I put the example on the e-learning also lah, that I can I have get from internet. Okay, So basically, the MapReduce been done here. Any question? Now, are you clearer after I explained just now the example? Better? Now, do you understand better what I mean? The hand in hand, the computation and the block are together. They are run together. Now, if you understand better, give me one. Just now you cannot understand the compute and the storage, the hand, but after you see the word count and then how they do a suffering behind the system, you do need to do that, then it become easier. Map reduce sensor. Can you see my screen? Oh, okay. I'm not sharing screen yet. These are Java version. You can download Hadoop, export, right? And you can configure the Hadoop cluster. I will upload this to the e-learning as well. Okay. For the programming part, but these are machine are available in the USM. So you are out campus, so you cannot. They are firewall, so you cannot access to the machine. But you can see the example. Okay. So when you run the input file, it will generate elephant and so on. Okay, Cassandra is the other one. Okay. The example of Hadoop example. Program. Okay, I think that's all for today. Okay, so everyone, any questions? Open question now. Q&A. Zhao Jing are using Python for MapReduce, right? Not difficult. Okay, they got Java, they got Python. Okay, so far so good. So now I will end the today's session earlier. Okay, so finish. Okay, that's all for today. Bye bye.